Okay, so I think we should be live now, and welcome everyone to the Diffusion Models live event. This is part of a course that we're offering with Jonathan Whitaker, and I'm really excited today. We're going to have a range of speakers from the creators of Stable Diffusion to David Ha from Stability AI to Devi from Meta AI and several other people. So if you've got any burning questions about, I don't know, schedulers or noise or anything like this about diffusion models, today is the chance to ask them. And my name is Lewis. I'm from Hugging Face. I work in the open source team on transformers primarily, and I'm slowly getting converted to diffusion models, which is why I'm here today. And I'd like to introduce Jono Whitaker, who's the creator of the course. And he will talk a little bit now about what the course is about, and then we'll dive into the talk with David. So with that, I'll let you take over, Jonathan.
Great, thank you, Lewis. Hello, everybody, and welcome to the Hugging Face Diffusion Models class. So this is something that sprung up predominantly because obviously you're all here because diffusion models are this very exciting, kind of newly popular class of models for generating things. And so everybody's excited about them. And what I think there was a big gap, especially when the first wave of excitement first rose, was that, everyone's excited about this, but not too many people are able to then take ownership of that and start building on it because it's all quite new. So this course, we're very excited just to try and introduce these ideas to get you up and running, specifically on like using the diffusers library in this case, but just more generally trying to understand the different concepts from the basics all the way up to something like Stable Diffusion, taking it, fine-tuning it, adapting it, and really understanding all of the pieces that go into some big complex system like this. So at the moment, it's just Unit 1 that's out, very much the introductory material, but hopefully enough to get you up to speed with the core ideas. And then from here, we're just going to build on probably every couple of weeks a new unit. And I think the first 4 are listed, but there's hopefully more in the future as well as things like diffusion for audio, for example, becomes more mature and we're able to like capture that into something that's worth learning rather than something that's too rapidly changing. So very excited to share this with you all, and also super excited for today to see what all of our guests have to share with us, which brings me, I guess, to introducing the first speaker. So very much a warm welcome to David Ha. Until recently, David was a researcher at Google on the Google Brain team in Japan, but just in the last few months, he has switched over and is now head of strategy at Stability AI. So very excited to hear from him. And his research interests are, complex systems and self-organization, and also just all of these creative applications of machine learning. So David, very great to have you, and I look forward to seeing what you have to share with us.
Oh, thank you. I'm gonna share my slide now. Can you see my full screen slide?
Yes, we can.
Okay, thanks. Thanks a lot, Hugging Face, for your kind introduction and for letting me give a talk. Just as a warning, the rest of this today will be many talks of like many technical talks, but this talk is going to be a general non-technical talk because I've been invited to give a general talk about creative AI in this course. So I'm David Ha. I currently work at Stability AI, and I joined around actually only 1.5 months ago, but somehow it feels like a whole year has gone by. This space is happening. There's so much going on right now. Things are going really fast. And before joining Stability AI, I worked at Google Brain as a researcher for 6 years. And in this talk, I really want to dive in the topic about collective intelligence and how that is related to creative AI. And the material in this talk sprang from a conversation between myself and my collaborator, Dr. Judy Fan, who's also a machine learning researcher, but also a psychologist in UCSD, and also he's going to Stanford next year. And basically, with everything going on in I started doing machine learning research around 7 years ago, and also started working on creative AI, like working on generative models for music and sketches and so on. But it's really that this year things really started to explode with the advent of text to image models and diffusion models, and things are happening at such a fast speed that like I always question, and I was discussing with Judith earlier this year, like what's going on. We want to make sense of it. And we had lots of discussions. We dived into some of the literature in behavioral studies in the past, and I think we really have to understand how people in general, the population or the collective intelligence, is using these technologies and interacting with them to really understand how why things are going so rapidly and things are being adapted and at such an exciting pace. So in this talk, I'm gonna mainly focusing on my experiences with this technology, and through understanding the collective intelligence or how people collectively use it, it might help us develop a framework for understanding how these text-to-image models, or more broadly AI tools, augments human creative expression, and may help us understand why things are really taking off this year. So let's dive in. So I really like to study complex systems and collective intelligence because I think these systems are beautiful and they lead to lots of resilience and robust properties. One of my favorite quotes is from this book from Andrew Pickering in The Cybernetic Brain, where he mentions bridges and buildings are all designed to be indifferent to their environment, to withstand fluctuations, and not to adapt to them. The best bridge is one just stands there, whatever the weather. So I think the contrast between a really well built bridge versus like a bridge that's built by a bunch of agents, in this case ants, that were formed through emergence is a sharp one, and it's a metaphor for what's going on in the technology space right now. So on one hand, you have very large structured models that are designed to do things really well, and on the other hand, you can have open source models or people, hundreds or thousands of people hacking around models, taking them apart and making things out of them. So I think these two approaches is kind of at the core of what's happening in the open source community right now, and it's going to be a theme of this talk. And when I think about image generation from a collective intelligence, we can think about GANs or VAEs or Stable Diffusion. But one experiment I really like is the image generation experiments using humans as an algorithm on Reddit in this rPlace experiment. So this is, if you haven't heard of rPlace before, it's basically collective intelligence applied to image generation. It happens around once a year on some years, and they basically set up a 1,000 by 1,000 pixel canvas. So there's a million pixels, and each Reddit user is only allowed to draw one pixel every 5 minutes, and the entire experiment lasts for a week. So the user, in terms of the exploration space, has like 1,000,000 times 256 possible color possibilities. So there's a wide range of exploration space. From the user's point of view, the user also wants to share and collaborate with other users. And what's more interesting is the network dynamics also affects what is drawn as well. So there's three properties: the exploration space, there's also the drive to share and to act in the environments, and for the user to get feedback from this complex network in this million pixel canvas. So what happens is the users on Reddit, without any explicit reward signal, even coordinate some strategy on the Reddit discussion forum to defend some design, to attack other designs, and to form alliances. And this, seemingly like a non-objective task, leads to these awesome, lots of these patterns and resilience, robustness going on. And I think this kind of epitomizes many things that are happening right now in the diffusion models space, in the open source creative community. So I think this is something that it really resonates with what's going on in the machine learning space as well. So if we talk about machine learning in particular, like generative AI algorithms, the collective intelligence, or like a collaborative generative AI, is not something that's so new. Even back in 2007, Ken Stanley published a paper called Compositional Pattern Producing Network, or CPPNs, which are like a method to evolve neural networks that can generate patterns. And what he did back then was he put this algorithm on the internet. Back then, when there's no JavaScript, but it was based on Java applets, and he let it loose. So Ken Stanley and his collaborators put this CPPN algorithm on the internet, and users started to evolve networks that generate these cool patterns. And what is interesting about these networks is some user can take some of these networks and continue to evolve them in some way, so they can kind of innovate and build on top of them to generate other algorithms as well. So this leads to more and more complex but interesting patterns being discovered by like a community of users around this platform, which he called a pig breeder. So when I first got into machine learning around 7 years ago, or 7 or 8 years ago, I played around with this CPPN algorithm as well. I re-implemented it in JavaScript, and this is kind of how it looks like. You evolve a network on the writes, you feed in the x and y and the distance from the center coordinate, and the network outputs the RGB value, the color. So in principle, this can generate very high resolution images because you're not confined with about how many pixels you are. You just put in the coordinates. It could be any coordinate you want, and you get a color. And as these things complexify, I was able to generate very complicated images that look kind of cool. And this was back in 2015, and like when GANs or CFAR 10 was at 32 by 32 resolution, and I thought it was kind of cool to have a neural network generate 2048 by 2048 pixel images back then. So when I got into deep learning, the first thing I did was to apply these CPPNs to MNIST, because I was sick and tired of MNIST. It was like 28 by 28 pixels. It's so uninspiring and low resolution. So I immediately used these methods to generate 1,000 by 1,000 pixel images of MNIST even, and also evolving all sorts of abstract patterns using these CPPNs. So I was fascinated by looking at what has been created from this sort of a collective or communal AI algorithms, and how they can be applied to deep learning. And later on, when I joined Google, and I also worked with a team called the Google Creative Lab, and they also built something very inspiring. They built a viral game called Quick Draw, and they collected basically the collective knowledge of how to doodle things on Earth using a quick draw game, where basically they have around like hundreds of categories, and users were asked to doodle things in 20 seconds that resemble that category. And somehow they collected hundreds of millions of images. For some reason, people were addicted to or really enjoy playing with neural networks. And this is a theme that's kind of recurring right now as well. People like to have an interface to work with an artificial neural network, just to see what happens with that artificial neural network. And they like to get the feedback from that artificial neural network, so they can play a game again. It's kind of like what's happening now with diffusion models, but back then it was a lot simpler. And here, the Google open sourced the data sets of like tens of millions of these doodles, and it was pretty awesome. It was like the first large collective data set of doodles all around the globe. And of course, the first thing I did was I took this data set and trained a generative model on it. So I trained an algorithm, a recurrent neural network called SketchRNN, that can take doodles and continue to draw them so you can draw things like continue to draw gardens, faces, and insects, and buses, and so fire trucks, and so on. And I really like playing around these models interactively, just like how now when people use diffusion models, you like to have a very short feedback between seeing the output and typing another prompt. Back then, I made these models work in the web browser, so you get instant feedback. So after you finish drawing, the machine will take over right away and show you what's going to happen next. And I think this short feedback cycle is really important for machine human HCI when we're trying to get people to creatively interact with these algorithms. I started playing around with extending this to multiple inputs so that you can sample different seeds. Like how when you're using diffusion models now, you don't just generate one, you want to generate 9 or 16 and choose the best stuff. So this is kind of like back then you want to generate all of these and get inspiration from as many randomness as possible. And just like now, back then I also tried to open source these models and release it for everyone to use. And it was just amazing to see how the community took apart all of these neural networks in the wild. And one of the things I saw was that people deployed them on robots, and they were drawing doodles of cats and birds, and even someone took the sketch-RNN model and projected some outputs to a building, and that was pretty cool. What was really interesting back then was that even in 2018, 2019, there was a student at Berkeley, Forrest Huang, who actually looked at quick draw data set and sketch-RNN and used the concepts of prompts and put them into embeddings. And he had a paper that took a short text description and tried to create a doodle based on that description. So this is a very rudimentary version of modern text to image, but it was text to doodles. And I think one of the things I liked was that doodles were really simple, so he didn't need that much resources to train this model and able to test out these early versions of text to image algorithms. So of course, 3 years later, the world has completely changed, but I thought this was a pretty cool work back then before text to images really took off. So around that time, I was working on many research problems, and fast forward a few years, just from April of this year, when OpenAI and Google started demoing their text to image models, I had fantastic experience playing around with text to image models. You may look at my Twitter, and my Twitter feed was full of these examples. So I really like to play around with DALL-E 2 and Imagen at the beginning. When I started using DALL-E 2 and Imagen, I knew this was going to be a game changer. It's going to change the world. Like I actually thought they were a bigger deal than pure text generation models like GPT, because somehow the human perception system, the visual system is so attached to our senses, to our inner self, that we feel a lot more motivated and have a stronger emotional response when we look at the images compared to reading text. And I think that there's two types of initial applications. Like people were making arts using these models, and also making photos of weird stuff, like a photograph of a strawberry frog. And what was really weird, it seems it was only this year, but it seems like such a long time ago that, like, remember back in April, only a small minority of people had access to DALL-E 2 or Imagen. I remember back then, it's not like now everyone can download Stable Diffusion or whatnot, or get invites to Midjourney. But like I was only a handful of people in the world who had access to DALL-E 2 and Imagen, and it felt weird. It's like there's only a small number of users, and I felt like something was weird and kind of wrong, because I think this amazing technology should just be available to everyone. But I had access to it, so I played around with it, and I started off making images like many of you, with known artistic style, like having cyberpunk digital art, or making Banksy images of Totoro. Then I tried to create some images with some degree of realism, but it's kind of like a fantasy, like the robots, romance, or beers, like bears drinking beer and eating ramen in Shinjuku. These look kind of cool. And then you can try to create some images with some degree of emotion, which is possible because of a diverse data sets and the embeddings. And you can have like robots dating, or cats trading on a stock market, and so on. And what captivated me about these models is their ability to learn abstraction. So one of my motivation on the earlier Sketch RNN and Quick Draw experiment was I wanted to understand how humans like ourselves develop abstract concepts of things, and then we doodle very simple representations of those things. But somehow these models can just learn that. Like we can ask the DALL-E 2 to create a minimal line drawing of New York City, and it does that. It can create like Lego figures of Jay-Z, Jeff Bezos, Arnold Schwarzenegger, and Rihanna. And it has to kind of learn some abstract representation of Rihanna or Jeff Bezos or Jay-Z to make Lego figures from them. So I think these are pretty convincing example that they're able to learn abstractions. As you know, I post a lot of these images on social media earlier this year, and I kind of monitor some of the engagement. I noticed that the images with the highest engagements are often not the ones that look the most beautiful or realistic. Like good art doesn't get retweeted that much. Is the ones that have involved cultural factors or kind of memes. So like one of the my favorite one is this photograph of a bear stock market in the 1930s. As you know, this year sucked for stocks and everyone's losing money, and I tweeted that out. And the fact that the bear market got interpreted as a bear, and the market was actually going down, made this popular, made this image with this kind of a misinterpretation really popular. And Bitcoin was also tanking, and somehow was like people like Japanese art. So Japanese ukiyo-e scrolls with Bitcoin was also a trending thing. And these models were also great at making novel combinations of very distant concepts. Like no one expects Darth Vader to be on the cover of Vogue magazine, and maybe no one expects, like maybe some of you, but Darth Vader at a tech conference. Maybe he's trying to pitch some deal in a bad market environments. And one of the things that really shows the brilliance of the community is the ability to reverse engineer closed models. Like I'm sure many of you know that DALL-E 2 has some the safeguards or like limitations, or where you can't type in profanity. And some users, not me, like type things like "fuck you" and get Elmo to generate that as a text image. It's kind of funny. And people also reverse engineered how the system was inserting prompts into the algorithm. So they had a prompt that says a person holding a sign that says, and then suddenly there will be a sign that says female or black, as a way to debias some of the images. So the community is pretty smart. Humans are pretty smart as a group to figure stuff out. So by June of this year, I was thinking, what's next, right? These are pretty amazing stuff. Was at that time I was thinking, was the future of text to image models dominated by big companies like OpenAI, Google, who have the resources to train bigger models on bigger data sets? And there's a plot twist. In the middle of this year, there's a huge spike in the usage of this model called DALL-E Mini. So DALL-E Mini is a community effort funded by Hugging Face. I think it's a hackathon by Boris and led by Boris, and they try to reproduce DALL-E 1. And they were successful. They created a model that can generate stuff from text, generate images from text. That it's not a high resolution. It's like 256 by 256, and Hugging Face served this model on the Hugging Face Gradio or whatever the demo, and it became a viral hit. What was amazing is at some point this year, DALL-E 2, not DALL-E Mini, became an absolute viral internet meme. Like, we're on ML Twitter and ML Reddit and so on, but none of that matters. Like much broader than that. People actually like associated text to image with DALL-E 2. And many people were kind of surprised by that. But it turns out that DALL-E 2 because of the low resolution and the 3x3 grid, is great at making memes like, you know, M&M as an M&M. It actually makes an M&M as an M&M. So people loved it. It gotten so popular at one point that the New Yorker made a cartoon that featured this iconic 3x3 grid on the tweets, and it was written up on Newsweek, because you're able to make funny images of Trump and Biden using DALL-E 2, which was probably prohibited from DALL-E, using DALL-E Mini, which is probably prohibited from DALL-E 2. So people even made a meme for this DALL-E Mini. Like at the beginning, DALL-E 2 was rolled out to a selected group of artists, but then at the same time, people started using DALL-E 2 to make minions at Cross Burning, Jar Jar Brinks at Nuremberg Trial, and do things like gender reveal 9/11. It's kind of funny. And I think when DALL-E 2 came out, it really offers a hint of creativity of the masses being unleashed. And this sort of a casual creativity is something that's really apparent in these text-to-image models. Like people can take these concepts like gender reveal and make Death Star explosion gender reveal, funeral at Walmart's, or neurosurgeons putting ramen inside a man's head as a joke. And it would generate it, and it's hilarious. And I think, you know, what made these viral is these models are, it's not just about scaling the model size or compute. I mean, that's important to get some quality, but just as importantly, I think the success of DALL-E Mini is about scaling the number of human users and developers that's using this stuff. Like there's like an evolutionary approach, like people play with this model and upload their favorite ones, and the community will upvote the ones that they think are the most popular, and hence you get these meme images that come out on top. So, and what's also apparent at the time, many of you know now, is like what works on one model does not work on others. Like when you type in YouTuber doing a funeral unboxing on DALL-E Mini, it's pretty funny stuff. You get this like, you know, tech bro unboxing, like a funeral, like a coffin. But if you put the same prompt in DALL-E 2, it doesn't really work, right? So these images, the best images are actually a result of not just the model, but a complex feedback loop between a human or the community of humans and a neural network model. So another thing that made DALL-E Mini popular is because it can be used to portray cultural items to reflect current issues. Like, you know, this year people generated Fisher Price my first hand grenade, or Supreme Court dressed as clowns. So you can probably, it's self-explanatory. And like when I was discussing this with my collaborator Judy, I think like we think there's many, we can distill it down to 3 processes. There's the motivation to share. So after exploration, using a text-to-image model, people want to share them, and through sharing the images in multiple variants, you get some feedback from the network that you share to, and think people build on top of it. So there's really we think there's 3 stages in this framework. There's an individual exploration stage of using the tool or the model to create an artifact. There's a drive to share, and there's a network of dynamics that will allow people to build on top of your innovation, just like the pig breeder experiment or CPPN experiment I discussed at the beginning of this talk. And then you get the feedback back to the user. So the first is mainly enhancing the person's ability to efficiently explore a wide space of possibilities, like individual exploration. There's also the model or the framework, or the like text-to-image models basically heightens a person's drive to share what they have created with other people. Maybe because text-to-image models is just so new and cool, people just want to share these things. Maybe it won't be the case in 10 years from now, or probably not. And number 3, the important thing is unlocking the feedback dynamics that accelerate innovations across large communities. So you share them and you get feedback, whether on social media or whatnot. And an example of these is like these innovations in the model are learned and passed on other users and are built upon. Like people discovered that DALL-E Mini was good at drawing sketches of courtrooms. So on a dinosaur, and people copied this concept and made a bottle of ranch dressing testifying in court, or alien appearing in court for damages caused by abductions. So these are pretty hilarious. People discovered that PlayStation is pretty good as well. Like it's Grand Theft Auto Tiananmen Square edition and American Psycho for PS2. So this is only one part of the puzzle. I think so. There's the individual creator or artist using these tools. We also think this framework can be applied more broadly. There in this space, there's the users and creators and artists using these text-to-image models or AI tools to create artifacts. There's also the developers that are working on these models or new ways to use these models or applications, and hence creating applications as an artifact as well. And also, sometimes the artist can also be the developer, so they can wear multiple hats. But there's like these two layers of loops going on, not just users but also developers. So I'm going to talk about this parts using Stable Diffusion as a case study, where we see things like creative applications, model hackers, and research. And boy, we can step from DALL-E Mini to the Stable Diffusion community. It's basically going from AI memes to AI arts. Like I think I have 5-10 minutes left. I think it's okay. So like the Stable Diffusion community is not just satisfied with text to image. They want to create arts and fantastic images from it. And boy, this community is weird. Like you get on the left like the model hack, like the model hackers that want to really make things look perfect and kind of criticize every single flaw. You get the normal users that just wants to make memes like Paris Hilton and Albert Einstein, being wed to each other. And you also get the developers, like people hacking on Dream Booth to make pictures of their friend's wedding. So I'm going to talk about these three categories and of this loop. So in the area of creative developers, because the model is open source, it led to things like like hundreds of apps like Photoshop, Figma, Blender. People were writing plugins for all of these apps, and it's really difficult for one company to build plugins for everything. You really need a community of hundreds of thousands of developers. Like within days of Stable Diffusion initial launch, people built a Figma plugin that you can just use the Stable Diffusion model, type in a text prompt in Figma, and you would get like the realistic looking design from a text to prompt and conditioned on an SVG drawing or like a rendered SVG drawing. Blender as well. People were able to quickly develop plugins or various plugins for Stable Diffusion for Blender, because Blender is the open source standard tool for creating 3D scenes. People are able to take these like renderings in 3D wireframe images, type in a text prompt, and make them into various art pieces using Stable Diffusion. And like the other part I was talking about is the model hackers. There's so many model hackers out there, and this community really discovered novel ways of using Stable Diffusion. Things like negative prompts, how to combine models, fine tuning to model distillation. Like I think negative prompts. I'm not sure where it was discovered, but it was certainly made popular in Stable Diffusion. Like you type in the prompts that you don't want to see, and suddenly it makes your burgers look much better. We can chain together DALL-E Mini to Stable Diffusion models, because maybe DALL-E Mini creates more meme images, and you can create a higher quality version of gaming toilet made from NVIDIA RTX 3090 GPUs. There's also a whole bunch of hackers making fine-tuning custom models using Dream Booth or other techniques to customize models or on a particular data set. And this is something only possible with open source models, because with a closed source but very large model, it probably doesn't know who you are, or probably doesn't know some niche concept where like you actually want a smaller model that's good enough, and you can just fine tune it on your small data set to have a diffusion model that's suitable for your particular application. And what's funny is people actually try to get Stable Diffusion to generate styles that look like Midjourney by simply collecting Midjourney images and fine tuning Stable Diffusion model to mimic the prompt to Midjourney images, and you can kind of get Midjourney. They kind of discovered the concept of model distillation, rediscovered it by fine tuning Stable Diffusion into Midjourney data. That was kind of cool. And lastly, I think I'll go 2 minutes left. I'll talk about how I think open source diffusion models like Stable Diffusion will become a foundation of the research community. There's so many works right now that's actually using Stable Diffusion as the benchmark model to communicate results in the academic community and in the research community as a whole. Like, for instance, there's this amazing paper called Dream Proof. Many of you may have used it to fine-tune your Stable Diffusion models. It came out by this fantastic group from Google Research. I know everyone here. And like, it was originally written to be used with the Imagen model inside Google. But right now, if you say Dream Proof, people will automatically think that you're using Dream Proof with Stable Diffusion because it's what works out there and because of the open source model. Another recent cool work is this Instruct Pix2Pix, written from Tim Brooks and his collaborators at Berkeley, and they were able to combine GPT type model or language model with Stable Diffusion to be able to create to instruct the model how to edit the images using natural language. And I think these are things that are easily doable, with an open source model compared to a large closed source model. Even in the area of interpretability in machine learning, people are using Stable Diffusion as a base when communicating, their results. Like, they're using someone wrote a paper on interpreting Stable Diffusion with attention maps and so on. And I think Robin may talk about this later in his talk, but we think that Stable Diffusion is also going to become a popular model of choice for machine learning researchers working with diffusion models. And we think that the base model to conduct research on will become something like Stable Diffusion or an open source model because precisely it's open source. We actually think Stable Diffusion will probably become something like a VGG or AlexNet model in the academic and industry ML research community because people can communicate and speak in the same language. And even lastly, some areas outside of ML research, like health, are using Stable Diffusion. There's a paper called Rowan Gen, where a team built a generative model by fine-tuning Stable Diffusion on a large X-ray and radiology report data set. And they're creating new, generating new X-ray and radiology images using by modifying the text prompt. So I'm not sure how impactful that is, but this stuff is going on. And I think I don't want to go out of time, but I think this is just the beginning. And I think with the trajectory of this open source and community-led development, both on the user side, on the developer side, and the research side, the future is going to be really bright. So I don't want to go out of time. Thank you.
There we go. Hey, so thank you so much, David. It's an awesome talk. I think maybe the most number of memes, like actual memes, I've seen in a talk. So really, really cool. We've got a few questions from the audience. If you've got a few minutes,
Sure. I don't want to go over time because I think maybe we're still under time. Given that you took
a few questions just to see. So there's one here.
Yeah, maybe you can shoot one or two, and I can answer them.
So the first question is from IQ Mates, who's asking, as these models become more capable, how do we protect against deepfakes? And I think this is a really important question that is on the mind of everyone who's worried about generative AI.
I think so too. There's many opinions out there, but my opinion and my view is we should release these models as frequently as possible to the community. And I think that the community at large will be able to look at the dangers of these models or preventing deepfakes and looking at the dangers collectively and finding ways to mitigate them. I think this approach is much preferable than having one institution taking the responsibility of protecting the model, because there's so many instances of history where that doesn't work. Look at cryptography and so on. Why are these models are not that like perfectly realistic, generating hands with 6 fingers. I say just release them, put them out there, get people to work on safety aspects collectively, and I think the red team has to be in the open source world as well, to work together with the model development team to like push forward. Otherwise, you would just end up confining a model inside an organization, and it'll never see the light of day. And that model will eventually be leaked somehow, or people will reproduce it with once it's very high quality, and the community will not have enough time to develop the protection against it.
Yeah, that's totally agreed. I think also at Hugging Face, this is something that we're very aligned with about, doing things in the open, right? Because what we learned also in NLP is that when you have open source language models, people can actually then inspect them and, attack them, which is cool, right? I mean, it's not easy to do through an API.
Yeah, totally. And as I discussed in the last part of the slides, the interpretability research are using stable diffusion models as the base model.
Yeah.
And so this is actually happening right now.
Cool. So maybe we can take one more question, which is a bit of a eye to the future. So will text to GIFs or text to videos become the natural extension to the sort of current family of generative models, or is this still a difficult problem to solve?
I think it's a natural extension. Like if you follow the literature, Google has already published the Gen video work, and that's pretty awesome. I used it when I was there. It works, so we're already there, and it's only a matter of time when these results gets reproduced by the community at large and extended upon, and like hopefully when we, like the way I approach research or we approach research at Stability AI is not necessarily just reproducing stuff. We want to be able to innovate and optimize for efficiency, like where you don't actually need like a TPU pod to run these models, and we want to make sure that maybe you need a decent GPU might work. The quality might not be state of the art, but at least people can try to make gifts from it. So
Exactly.
that's kind of the dream.
I think it was you who said on Twitter that like the metric today is like, can it run on Colab, and then how many images per second? It's like
yeah. So it's a multi-objective optimization, I think, when we're making these models, and we just gotta get the best bang for the buck.
Awesome. So maybe we can end the broadcast there. So thank you so much, David, for joining us. It's been a real pleasure.
Thank you.
I really enjoyed the talk. And to everyone else who's in the audience, we're going to take a break now, and we'll be back at 6 o'clock Central Eastern Time. So catch you later.